Hi, team. We are actually in the last section on Unit 8, so we're on 144. And um, we've learned a number of different ways to factor, and we thought it might be handy for you guys to have a reference tool, this flow chart, to look at when you're deciding what to factor, how to factor. So I'm just going to run through this really quick. First of all, we talked about very first thing you need to do, first, make sure that your polynomial's in standard form. Are the exponents in descending order? If not, put it in standard form. And then jump back in and look for a GCF. Is there a GCF that you can factor out of each term? And this is an important statement right here. If the leading term is negative, so your highest exponent term is negative, that's when you factor out a negative factor. If your leading term is positive, you don't factor out a negative. Okay? So if there's a GCF, pull it out and come back down. If there's not a GCF, then you need to count the terms. If you have a two-term polynomial, you've got a binomial, and the very first thing you want to look for with a binomial is the difference of two squares. If it's got three terms, you don't have the difference of two squares, you're going to use the AC method. So this is a two-term binomial, three-term trinomial, AC method, and four terms we factored by grouping. Once you do all of that, you're not quite finished because you've got to go back and look and see, do I still have a difference of two squares in there somewhere after I've done one of these methods? And if you do, then you got to go back up and come back down again and keep looking until you are satisfied that there are no more factoring, no more difference of two squares, no more factoring that you can do, and then you're done. All right, so let's go take a look at some. I'm going to actually, at the top of this page, I'm just going to kind of write a little cheat sheet for us. We're going to look for standard form. We're going to look for the GCF, and then we're going to count the terms. And you can refer back to the flow chart as well. So very first thing I see in example A is this guy's not in standard form. The negative a to the fifth needs to come to the front, and the plus 81 a to the first power goes behind him. This is a good example of factoring out now a GCF. Yes, there's a GCF. It is A. But because this leading term is negative, I'm going to factor out a negative A. That's going to leave me with a positive a to the fourth, excuse me, and a minus 81 inside the grouping symbol. Remember to check your work. Distribute back. Minus a times a to the fourth is minus a to the fifth. Minus a times minus 81 is a positive 81a. So we've done that. Now I'm going to look at the terms. This guy is just a leading factor. He doesn't have any terms. But this guy has two terms. And in fact, it is a difference of two squares. So the very first thing I'm going to do, I'm going to leave this negative a hanging out here. I'm going to rewrite this difference of two squares as the square root of a to the fourth, which is a squared. There's going to be a plus and a minus, and the square root of 81 is 9. So I'm feeling pretty good about myself now, but I still have to go back and look at my two-term factors that I have left. A squared plus 9, I can't do anything else with him. He's not a difference of two squares because he has a plus sign. But this guy, he can be factored further. So I'm going to bring down what I've already got, and I notice that this is the difference of two squares. So I'm going to do a plus 3 and a minus 3. And that's the answer right there. Lots of factoring going on. All right, let's look at number 2 quickly. Standard form, 4 to, and it's okay that you don't have a 4 cubed or a 4 to the x cubed or x to the first power, as long as what you do have is in descending order. So yes, it's in standard form. Is there a GCF? No, there's not a GCF because there's no x in this last term and there's no common number factor. So I'm now ready to count the terms. there's 3 of them, I'm going to use the AC method. That's the only method that we know for 3 terms. So A is 1, B is negative 17, C is positive 16. I need AC to be positive 16. That could be a negative 1, negative 16. It could be a positive 1, a positive 16. It could be a negative 4, negative 4, or positive 4, positive 4. Also, 8 is a possibility. So it could be what? 8 and 2, or negative 8 and negative 2. If you already see the pairing, because it's got to add to negative 17, if you have found your pair, which we did right here on the very first one, you don't need to keep going. You're done. Once you have found a pair of factors that multiply to positive 16 but add to negative 17. So I'm going to rewrite, I'm going to, what am I doing here? Yes. I'm going to rewrite this x to the 4th. I'm going to move him over a little bit. And then I'm going to rewrite this guy as negative 1x squared minus 16x squared. So I'm using this guy right here, and I'm breaking this guy up into 2 terms instead of 1, and then the plus 16 on the back end. So are we good to roll? So what can we do here? We can group. What can we factor out? An x squared. That leaves me x squared minus 1. Factor out a minus 16. Watch your signs here. That leaves me x squared minus 1. Remembering that this negative times this negative is going to give me this positive 16 here. So now I have these that are the same. They can come to the outside. They're factored out. What's left on the inside is x squared minus 16. So you might think you're finished, but obviously you're not finished, because both of these binomials happen to be the difference of 2 squares. So we're going to write this one x plus 1, x minus 1, and this guy is going to be x minus 4, x plus 4. So now I have a whole bunch more binomials, but none of these have a squared term in the front. So once you see that x is not squared anywhere, then you can stop, even though this is a difference of this guy is squared and 4 is a square. Because the x isn't squared, you are done. Let's just do one more here, and then maybe I can just do one more video, and we'll be done with this section. So again, I'm going back up. I'm asking myself these 3 questions. Standard form, GCF, count the terms. Standard form, 4, 3, 2, 1, looking pretty good. GCF, well, these are all even numbers, so I know I can pull out a 2 at least, and they all have an x to the first power. So that leaves me with x cubed plus 3x squared minus 4x minus 12. So this is looking pretty good. Now I've got 4 terms here, so I'm going to look at grouping. I'm going to leave this 2x kind of hanging out here by himself, and I am going to pull out x squared as a GCF of these 2 terms. So that leaves me with x plus 3, and that's a minus sign, remembering we're going to have a negative action going on here. That is going to be x plus 3 also. Negative 4 times x is negative 4x. Negative 4 times positive 3 is negative 12. So now I've got one more set of factoring to do inside these larger parentheses. I am going to, maybe more than one, I am going to factor out the x plus 3 that's in common. What's left? X squared minus 4. So this is all well and good, except this guy right here is the difference of 2 squares. So I am going to leave my 2x as a factor, leave my x plus 3 as a factor, and rewrite him as x plus 2, x minus 2. I want you to notice that this 2x is not distributed. There is no addition or subtraction going on once you pull out this common factor of x plus 3. So you don't need this extra set of parentheses, and you don't need to do anything with this 2x at this point, because he is not going to be distributed, because we've gotten rid of all the addition and subtraction between our factors. Okay, thanks for watching. We'll carry on here.